problem number 3. We have this rectangle, ADEH, and we're told that points B and C trisect the length AD. Okay, so if it trisects it, it breaks it up into 3 equal segments. So this segment, and this segment have to be equal to each other. Okay, because we're told it's trisecting it. And we're also told that F and G trisect this side HE. Okay, so again, this length, and this length have to be congruent. So, and we're also told it's a rectangle, so that means that we've trisected, two opposite sides, which have to be equal to each other. So, the lengths, HG, GF, and FE have to be the same as lengths AB, BC, and CD. Okay, so they're all the same length. And then we're told that AH is 2. Okay, so this length of this side is 2. And AC is also 2. So from A to C is 2. Okay? And we're asked to find the area of the quadrilateral WXYZ. So we're talking about, let's see, I'll pick up a highlighter and highlight this for you. So it's this area right in here. Okay? So my highlighter is a little wide to color it neatly, but so you get the idea. So this is the shape that we're trying to find the area of. Okay? So let's take a look at this. I'm seeing here we have 2 by 2, right? We have 2 down, 2 over. So if we were to connect, if we would draw a line connecting F and C, we essentially have a square over here, right? So ACFH is a square. It doesn't really look like a square because when I did this, I intentionally distorted it a little bit. I sort of stretched it out this way a bit too, so that you just couldn't eyeball it, and and you had to use your reasoning in order to solve the problem. But essentially, this is a square, and okay, so we've got these diagonals here too, and you can see we're cutting this 2 by 2 square in half, and if we cut a square in half, we're going to get two 45, 45, 90 triangles. So this is 45 degrees, this is 45 degrees, up here there's 45 degrees, 45 degrees, okay, because we've just bisected this square. And since all these, I guess the other thing we could figure out is that since all of these segments are congruent, and this is 2 of them, then this segment has to be 1. CD is 1, right? Because AC is 2, made up of 2 congruent segments, so each one of these is 1. So CD also has to be 1. And the same across the top. These are all 1. Okay? And so what else can we do here? Oftentimes a good way to solve these problems is to break the shape up into congruent shapes. So what I'm going to do here is I'm going to draw some more parallel lines. Now, one thing you might notice is that okay, so we've determined that this is 45 and this is 45, and down here we have up here we got a couple more 45 degree angles, and with the same reasoning we can show that this is 45, this is 45, this is 45, this is 45. This has to be 45. This has to be 45. This has to be 45. Okay, and you can see that essentially, again, over here we've got a 2 by 2 rectangle. This BDEG is also, sorry, 2 by 2 square. BDEG is a square as well, and so this line DG cuts in half. So we have a 45 degree, we have two 45, 45 triangles, okay? And you can see that this diagonal here, to to go from A to F, we would go up 2 and over 2, right? Or over 2 and up 2. So, in the same way here, this diagonal BE, to get from B to E, we go up 2, over 2. So these lines are parallel, okay? I'm going to draw something in here. So AF is parallel to BE, okay? And we can also reason out that DG is parallel to CH, okay? And so I'm actually going to draw some more parallel lines in here, which will help me break this up into congruent shapes. Okay, so I'm going to draw another parallel line. Now we're going, this one is up 2 and over 2. This one is up 1 and over 1. So this is parallel also to these other ones. And I can draw another parallel line here. If I go up 1 and over 1, okay, up 1 and over 1. This is 1, this is 1. So this has to be parallel. Okay. And I can also draw another parallel line in here. Okay, I'm going over 1, down 1. Okay, here I went over 2, down 2. So these angles are the same. And so this is parallel to this, is parallel to this, and I can draw another one here. Okay, so down 1, over 1. So again, it's 45 degrees, and so that's parallel. All these are parallel. Okay, so essentially these are squares. These should meet here and here, and these should be 1 and 1. It's breaking that length, that side length of 2 up into two segments that are 1 unit each. And we have squares in here. Okay, so here's a square. This thing here. So these are all congruent squares too. Okay, and we have 1, 2, 3, 4, 5, 6, and 7. Okay, so ignore that dotted line. So this whole thing here is a square. All right, and then we have these triangles along the sides. Okay, we have 2 on each end and 3 across the top and bottom. And they're 45, 45, 90 triangles. And so they're just half a square. They're essentially half of one of these. So we can put 2 of them together and form a whole square. Okay, so so let's see, how many squares could we get out of these? How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. If we pair them up, we could make 5 squares. Okay, so we have 5 squares that are made out of the triangles along the sides, and then we have 7 squares in the middle. Okay, so we could if we cut this thing up along these lines here, we could end up making 12 squares. Okay, so we get 7 of them here in the middle, and then we get 5 of them by putting together 2 triangles. Okay, so 12 squares. And we're trying to find the area of one of them, right? That's what W, X, Y, Z is one of those squares. Okay, so we divided the figure up into 12 parts. Well, more than 12 parts. We have 7 squares and 10 triangles, right? So we have actually 17 parts, but we formed them into 12 squares. And we know the whole length, the whole area. We could figure that out easy enough anyway, because we're told what AH and AC are, and we're also told that these these points trisect the sides. So the side length of one side has to be 3, right? All the way across. EH is 3 and AD is 3. So we have the total area, so the area of the rectangle is what? It's just 2 by 3, which is 6. If we break that up into 12 squares, then 6 over 12 is 1/2. All right? So, so one of those squares is just has an area of a half. Okay? So that's our answer, is that the square in the middle, xy, or wxyz, has an area of 1/2 square units. We don't know the units, so I guess I won't put anything on there. We don't have centimeters or inches or millimeters or anything. So the answer is that the square w, x, y, and z has an area of a half.